In this example, we have 0.10 moles of CH3, NH2 or methylamine, and 0.12 moles of CH3, NH3 plus, and it's given in the question that this is the acid in 1 liters. So to start off, we know what our weak acid is. So we know that our weak acid is going to be the HA, which is CH3, NH3 plus, and our conjugate base is going to be CH3, NH2. Now that we know our weak acid and conjugate base, the next thing we deal with is our Ka or pKa. So in this question, we're given our pKb. So our pKb is equal to 3.36. Now we know that pKa and pKb add up to give 14. So our pKa is going to be equal to 14 minus pKb, which is 14 minus 3.36, which is equal to 10.64. Now that we know what our weak acid is, our conjugate base is, and what our pKa value is, we can move on to figuring out which reaction we're going to use. Now, as discussed before, if we add acid to our buffer, the reaction is going to be A minus plus H3O plus, going to form HA and H2O. This is when the acid is being added. And when a base is added to the buffer, we use the equation HA plus OH minus, which gives A minus and H2O. Now, in this question, we're given that we're adding 0.02 molar HCl, which is a strong acid. We are going to use this reaction. Now that we know our pKa value and we know our weak acid and our conjugate base, and we also know the reaction that we're going to use, we can move on to the ice table. So to start, we write down our initial conditions. So initially in the question, we're given that we have 0.10 moles of CH3NH2, which is our base. So we have 0.10, and since it's in 1 liter, the moles is going to be the same as the concentration in molars. We're also given that initially we have 0.12 molar of the acid. It's given in the question. So we're not given anything else in the beginning, but then as a change, or the x, we have for negative x, and we have a positive x here, we are adding more acid in, which, or acids give us H3O plus or H plus. So since we're adding in more acid or HCl, we're going to get more H3O plus or more H plus. So we're going to have 0.02 as the change. So the 0.02 is going to reduce the amount of base produced in the buffer, and it's going to increase the amount of acid as it neutralizes more base. And now as a result, we're going to have at equilibrium, or finally, after everything's done, we're going to end up with 0.08 molar of our base, and we're going to also have 0.14 molar of our weak acid. Now that we have the final concentrations, the pKa, and we have a reaction along with the weak acid and conjugate base identified, we can move on to the Henderson-Hasselbalch equation to see whether our pH change makes our buffer working. So we have our Henderson-Hasselbalch equation, which is pH is equal to pKa plus log of base over acid, which is the same as pKa plus log of A minus over HA. Our pKa is 10.64, and the concentration for our base is 0.08, and the concentration for our acid is 0.14. This will give us a final pH value of 10.39. Now this is well within the plus-minus range of the pKa, so we can say that our buffer is working, and this is the final result, or the answer, or the final pH that the example question asked us to find. Let us now move on to another example.